Okay, let's check out a live installation now. And the first thing that we're going to want to do, if you don't already have one open, is open a terminal. So on Mac, you'd hit Command space, and that'll give you your Spotlight search, and you just type terminal and hit enter, and that'll open it up for you. And on a Linux, you should be able to just hit Command and then start typing terminal. On a Windows, you'll want to go through the Start menu. Oftentimes, a search for terminal will bring up what you need, which is the command window, or you can just start typing command in the search of your Start menu. And once you have that open, we'll want to check to see which version of pip we have and if we have it at all. To do that, we just type pip space hyphen capital V and hit enter. And after a second it'll come back and it'll show us if we have it, what version we're running, and then it'll show us which version of Python it's running for. Now if you don't have it, on a Mac, in order to install, you're going to type sudo space easy underscore install and then pip, and you'll hit enter. And it'll ask you for your password, and you'll type that in, hit return again. And it'll go through the install, and it should finish up and give you some sort of success message. In this case, it's finished processing dependencies. Now, on Linux, it's a little bit different. In that case, you would type sudo and then apt-get pip, and you hit enter and type in your password just the same. So on here we won't do that because there is no apt-get on Mac. On Windows, then we need to head over to a browser in order to show you how to install that because it's a little bit different. So up here we can see that we have our site pip.pypa.io. So if you go to that address, we'll take the tail off here, then we can see this installation link. So all you have to do is click that, and we can see installing with getpip.py. So all we need pretty much is this line right here, and we'll download using this link, getpip.py. Once we have that on Windows, then in your command window, all you have to do is type python getpip.py, as long as the getpip.py is in the directory, the current directory that you're in for your command window. If not, then you can just move it or change directory. So with that, then it'll install pip for you, and we'll be good to go. But again, if you already have Python installed, chances are you have pip installed. So with that out of the way, in order to install TensorFlow, then for Mac and Linux, all we have to do is pip install TensorFlow. Now, there's also TensorFlow-GPU, and that's for installing the GPU version. If you just do pip install TensorFlow, that gives us CPU only. With GPU, often that's desirable, but for everything that we're going to run in these tutorials, we only need the GPU version. And if you wanted to, it would take a bit of effort because you have to install a lot of NVIDIA components, but you could for Linux or Windows. So with pip install TensorFlow, just hit enter, and we can see that I already have this because there are a lot of requirement already satisfied messages, but you should get some sort of success message when you install TensorFlow. And that's really all you have to do for Mac and Linux. The command that you would type in the command window for Windows is just slightly different. In that case, you're going to type pip -- upgrade install TensorFlow. So this is the line that you'd want to enter into Windows, and you should have a similar string of messages that should end with a success. So let's get rid of that. And now that we have the installation out of the way, we can move on to our examples. For running our first examples, we're going to start off with Jupyter Notebook. So that's the environment we're going to use to run these. If you're not familiar with Jupyter Notebook, I highly recommend you check it out because it's pretty great, overall really useful. But just in case, we're also going to run a couple examples in Terminal using both the standard Python environment and IPython Notebook. So the first thing that we want to do is import TensorFlow. And I'm going to import that as TF just to make the commands a bit easier for us. So in Jupyter Notebook, we hit Shift and return. That'll run that for us and create a new line. So with TensorFlow imported, then we're ready to go. That's all we're going to need right now. So our first example is going to be just a simple linear equation. It's going to have the form y equals mx plus b. It's a very standard equation of a line. And so in order to do that, we need a few things. We need m and b. Those will be tensors of a constant type, because those are constants in the equation. And x, well, normally we would call that a variable. In this case, for TensorFlow, it's actually going to be a placeholder because that's something that we're going to feed values into, very similar to the input layer of that we discussed earlier, the input layer of models. So that's where data feeds in. So let's create m and b. So m is equal to tf.constant, and we're going to give that a value of 3.0. And then for b, we're going to set that equal to tf.constant, and we'll give it a value of 1.5. Now, because m and b are tensors, even though they're constants, they count as nodes in a graph, which we'll get into more specifically in the next video. But in this case, since they're tensors, they're nodes, we can give them names. We're going to call them m and b. Okay, so that'll create our constants m and b. And then we need x, and that's going to be a placeholder. And for this, we don't specify a value because it's just an empty tensor. But we do need to specify a data type, and it needs to match our m and b. So we're going to say dtype equals float32. And then we're going to give this one a name as well. We're going to call it x. So hitting shift return, we create those nodes mb and x. And now what we need is a session object. Or actually, before we do the session object, let's create our equation, our function y. So we're going to declare y equals m times x plus b. And we'll hit return. So that just creates a new node, a new tensor for us, except this one is specifically the operation of mx plus b. And in order to actually evaluate y, we need what's called a session. So we're going to say ses equals tf.session. This is something else we'll get into more details about in the next video. For now, you don't need to worry about it. We're just going to create that. And now to evaluate y, do y.eval, and we need to feed in a value for x. So we're going to declare that x is equal to, let's go with 2. And we don't need the decimal there. All right, now we can declare that value, but in order to actually evaluate this, we have to tell it what session object it's going to be evaluating using. So session equals ses. And we hit return, and not surprisingly, we get 7.5, because we would have 3 times 2 is 6, plus the 1.5. We got our 7.5. So that's our first example, and we're going to take a look at a couple examples over in Terminal. We'll do a couple different examples, so you'll want to stick around for those. For the examples we're going to run in Terminal, we're going to start off with the standard Python environment, and then we'll just look at one quick final example in IPython, just so we can highlight that. What we need to do first is launch our Python environment. We'll do that by typing either Python or Python 3, depending on your circumstances and your installation. So I'll type Python, hit enter, and we get our new command prompt. First thing we need to do is import TensorFlow, just like we did in our Jupyter notebook. This time, instead of doing a linear equation which required 2 constants and a placeholder, we're just going to do a few examples with matrix operations or tensor operations. But that requires us to have just a couple constants. So we're going to create one constant, matrix M, or a second rank tensor. We're going to make that a 2 by 2 matrix, and we're going to give that values 1 and 2 in the first row, and 3 and 4 in the second row. And make sure to declare a data type. And then let's create a rank 1 tensor, which will be a vector. We'll call that V. Let's give it values 5 and 6. And we need to make sure, of course, that has the same data type. And notice here we didn't create any names. That's because it isn't required. We're just not going to worry about that here. Okay, so we have our two constants. Let's see what happens if we just try to add these together, m plus v. All it does is return a tensor. That's because we need to actually run this using our session, which we haven't created yet. So let's go ahead and create a session. So you'll see these output lines. These aren't any errors that you need to worry about or anything. They're just kind of general messages that may be useful to some people, but we can still run everything just as we need to. I'm going to hit return a couple times to give us some space from that. And so now that we have that, we can actually run. We're going to use ses.run, and we're going to do m plus v. And we can see here that we have element-wise operations that were performed by adding the vector v, which had values 5 and 6, onto each row element-wise. And that gives us 6, 8, 8, and 10. And then let's take a look at multiplication. So this is also element-wise. It's not matrix multiplication, but we'll take a look at that. So it multiplied our vector v onto each row element-wise of m, and that's why we still have a 2 by 2 array coming out. Now let's go ahead and look at using matrix multiplication. The one problem we'll run into is that our vector v is a rank 1 tensor, and so it doesn't have a matching shape in order to be multiplied onto m. But what we can do, at least not matrix multiplication, what we can do is use a reshape method that TensorFlow offers us, almost identical to the NumPy method, in case you're familiar with that. So let's go ahead and do, let's just do it this way, ses.run, and then we're going to do tf.mapmul. Mapmul is the matrix multiplication method, and so we put those in order that we would write them in an equation. So for example, if we want v to come after m, then we need to put m first, so that v will be multiplied onto m. And in this case, we can't just do v. That would give us the error. So this is where we're going to use the reshape. And for that, we're going to call v as the first argument, and then we're going to pass a shape in square brackets. So for proper matrix multiplication, we want this to be a 2 by 1 tensor. And so with that out of the way, we can get our result, which is a 2 by 1 column vector as expected for matrix multiplication. That gives us the 17 and 39. If you'll recall from one of the earlier slides, it'll show you how this operation was performed. It just happened to show you for two 2 by 2 tensors instead of a 2 by 2 and a 2 by 1, but it's extremely similar. All right, so now let's go ahead and take a look at an IPython example. But first, we're going to have to exit this. In order to exit our standard environment, we type quit with 2 parentheses and just hit enter. I'm going to clear that, and then I'm going to open up IPython just by typing IPython and hitting enter. So this is somewhere between the standard Python environment and the Jupyter notebook we were working in. In here, we get syntax highlighting, and we get these in and out cells. It's just not quite the same because we can't go back and edit them later. But it's much cleaner, easier to use than the standard Python environment. So we'll see the syntax highlighting here, import TensorFlow. And let's go ahead and first create our session. Again, we'll ignore those lines. And so in our new input here, let's go ahead and do just some quick addition just to illustrate this. So let's do x equals okay, so before I clear this, we just created x and y, which are just 2 simple constants, except x is a rank 1 tensor and y is a rank 0 tensor because it is just a scalar value, but we can easily add that element-wise to x. They have the same data types. In this case, we added the decimal just to get the inferred data types. So we're going to do x plus y, and there we go, our output array of x plus y. So that finishes things up for our first examples and overall the installation and introduction to TensorFlow. In the next video, we'll cover a lot more things in detail, as well as getting started with some of our first models.